Hey everybody, welcome back to the series. So, in this part of the series, what we're going to be doing is simply making our own custom file types that work on our operating system. And the reason we're going to be doing this is, well, first of all, it's fun, and second of all, I don't really see why we're making our own custom operating system if we're not going to be doing things like if we're going to be copying Windows file types and stuff like that, like it doesn't really make sense. And third of all, because since we're making our own operating system, obviously we want to do things better, do things our own way, that kind of thing. There's really no purpose to this, but it's just more to make, because it's fun and to make your operating system more geared towards you. Basically, all we're gonna do for the first start, I'm just gonna do a little lesson on what file types are. So for example, a file type we all know is text files, and you probably never thought of text files more than just like text. As you can see, you probably just thought that this text file contains the data A, B, C, but that's not really the case. That's just what your text editor interprets the data to be. So there's a way to check what the actual data is. So what I'm going to do is just open my file on a little bit of a hex editor online. There's nothing special about it. And as you can see, just by looking at the properties of this file, on the center of my screen here, you're going to notice that it's 3 bytes, and that's actually the data in the file. And you remember that I put 3 letters in. Each letter is a byte, and the way to see what the bytes actually are is just by opening this. You'll see that the A is equal to 61, the B is equal to 62, the C is equal to 63. I don't know if I could write something in here. If I put like 44, if that was random, as you see, that happens to be a capital D. Now, this is how every single, this is how C# generally manages files. You basically put in bytes. You can make the bytes whatever you want. For all I know, if you're making, this isn't true, probably, but if you're making a movie file, like a video file, the byte 62 could mean stop the video here, or something like that, It could mean anything, depending on whatever file type it is. But in the text file, 62 happens to be a lowercase b. Now, this is how C#, this is how you write the files in C#, you write bytes. However, you can go even lower than bytes, and this hardly happens, but this is what we're actually going to be doing. So, I'm going to open up a text file here, and I'm going to show you guys what a byte is. So, let's say that I have 1 byte equal to like 11. Convert. You'll now notice that I have 8 bits. So for every byte that you have, which a byte can go from 00 to FF, and this is how it goes. You can go 01, 02, 03, 04, 05, 06, 07, 08, 09, 0A, 0B, 0C, 0D, 0E, 0F, and then 10, and so on. That's how the bytes are stored. And so for 1 byte in the value 00 to FF, it contains 8 bits. And as you can see, this, with a value of 11, happens to contain these 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. And this is the lowest you can go in terms of file. in terms of reading files. The lowest you can do is read bits. And C# isn't really a low-level language. It's a high-level language. So one thing that it doesn't not really used for reading bits that much. It's more used for reading bytes, because you can write bytes to file, you can't write bits to file in C#. And the only time I've really ever written bits directly is in assembly, which is like the lowest possible level language. Basically, whenever you create your C# application, what it does behind the scenes is converts it into assembly. That's how low of a level assembly programming language is. However, we're using C# to create an operating system, which is a very low level thing to do. So to me, it makes sense that we're going to use a low level concept to pair a low level concept with a low level concept. And one thing that you might be wondering is, how are we going to read bits? Like, what data can you get from reading bits? Well, I'm going to write an example of data from a file that I made that contains data. So I'm going to write an example. And there. Here is a 8-byte file. And the reason that it's 8 bytes is just so that it's 8 by 8. Here is actual data that works with a file type that I made. And if you don't, and you can decipher this just by looking at it. And in case you haven't, I'll do this. And if you still don't know what it is, all it is the letter, and it's the letter C. And although it may look like really blocky and low quality, you can increase the quality. And the way we do that is by, instead of doing 1 byte per line, we can make 2 bytes per line. And then we could now make it go 16 lines down. And there you go. I don't know if that's 16 lines, but I'm just showing that's how you would increase the quality. And now you have, I didn't actually do it, but like if I wanted to increase the quality of the C, I could do something like this, and now it looks a little bit more like a C. So that's the file type. And I've actually have one of these file types right here. And in case you haven't put it together, right, what we're doing is making fonts so that we can write our fonts on and write text on our console application that we were setting up in the last video. And I've made a little bit of a file beforehand that contains 1 letter only. So one thing that might catch you off guard is that it actually is 9 bytes. And that's because, along with a lot of applications, the first byte, or the first chunk of bytes in some cases, in a lot of cases actually, in most cases, is a header. And a header simply means it gives you an indication of what the file is going to be. So in this case, the header is 00, and it varies from file type to file type, but in this file type that I made, if the header is equal to this, or the byte value would be 00, then that means it is an 8-bit font quality, which is the first one I showed you guys. And then if it's equal to this, which is equal to 03, it becomes 16-bit font quality, which I also drew one of. And then it has support for this, which I believe is 13, and this, which is I think C3. And those are the bit. And if I wanted to create even more qualities, I could do it, but the quality that we're gonna be using is 16-bit. And if I open up a 16-bit font that I actually fully made, you'll notice that the first byte is 03. And there's actually 92 characters, that's why there's so much data. But this font only has one character, so theoretically, if I decipher these bytes into bits, I should be able to see what the first character is, which is an A. It goes capital A to capital Z, lowercase a to lowercase z, 0 to 9, and then symbols. So the first character is always a capital A. And let's go ahead and see if that's true just by going on this right here, convert this, FF. You get that. Luckily, there's only two different types of bytes, 81 and FF, so I can easily decipher this. And the 00, as you remember, it's the 8-bit font quality. And now I'll convert the 81, and we get this binary value. And then, we can now piece this together. Then there's 4 81s. And as you can see, this is an A. And if it's not obvious, I'll get rid of the zeros. So obviously we can read this. This is an A. Very simple. It's 8-byte. The reason I chose 8-byte for an example is because I don't want to sit through this entire, do an entire chunk of one letter, because it would take forever, of a 16-bit, let alone a 32 or 64-bit. But we can obviously decipher that this is an A. It might be low quality, but you can decipher it's an A. And how is a computer going to decipher it's an A? Well, it's going to go through every single byte. And that's harder to do in C#. First, we have to convert it to a string. So then we get that. That'll be our string. And it's going to go through every single one. And if it's every single number. And if it's a 1, that means draw a pixel. And if it's 0, that means don't draw a pixel. Skip it. And that's what we're going to be doing. So, what we're going to do now is go back to, and before I do that, you might be wondering how you're going to draw your own font. Well, I made my own font that you guys could copy, but I was running it, and it is my handwriting, and I rushed it, so it kind of looks like a 9-year-old's handwriting, which isn't far off from the truth. But if you want to make your own, I'll put the link in the description to the source code of this, and all it is, you can make your own font. You could choose which thing, and then you could write, you could just draw your own font. I know it says draw A, but I was just showing an E for an example. You could draw 92 characters. You could do any single size you want. As you can see, this would be 32, but as you notice, it does get a little bit laggier. It doesn't, oh, whoops. It doesn't, break it, but it's a little bit laggy. So I would recommend sticking to the 16-bit because it's not laggy. And not only that, but when we're doing it on our operating system, it's gonna be a good size. It's not gonna be a big size. It's a good size. 16-bit is a good size. So if you do 16-bit, the size of each character is going to be 16 pixels by 16 pixels. And I know a lot of you guys are going to be like, oh, well, we don't want to copy your code, that's why we're making our own operating system. Well, I just showed you guys how you can write your own fonts by hand. So if you really want to do that, then go for it. But you could go ahead and create your own font editor. The only reason I didn't make a tutorial on creating your own font editor is because this was a lot of work and it was completely out of my comfort zone. So I was making a tutorial on it would be really hard, but I was really happy when I made it because it's pretty difficult task for me, but and I didn't. It was just pretty fun to do. And yeah, you could just make it by hand or make your own font editor. I'm just not gonna make a tutorial for it, but I told you guys the format of the file, so it's very simple format. So you could do that on your own, and I also made a font reader. You could open your font and so you could test your fonts like that as well. And I'll be putting that in the description with the source code, so it's not malware or anything. It'll be on my GitHub, and I'll also be putting my own font if you don't want to make yours. But as I said, there is kind of a problem with that because it's very, very, very messy. But it works. It works. It's readable. And what we're going to be doing is making a font reader, basically, for our operating system. That's what we're going to be doing in this episode, in this part of this series. So going on our operating system here, we'll actually get to work now that we've got the basics down. In our graphics, as you guys remember, we made a tab, but this tab is just blank. So the first thing we're going to go ahead and do is go and right click on graphics, add new item as usual. And as you guys remember, what I was constantly saying is that we're making a console window, or console tab. And the console tab obviously needs text so that you could read or write. So that's why we're doing this. Right, console tab.cs. And the way that we make a tab class an actual tab is the same way that we made a command class an actual command. We put the colon and then we put the command. The only difference is we have to register commands here. We don't have to do that for tabs. So go back to our console tab and make it a tab by putting a colon tab. And what we're gonna do is we're gonna want the user to be able to select what kind of color they want. So we'll make public pen, console text pen, public font, console text font, and we're gonna have a lot of errors here because and that's just gonna be the font and the pen and the console tab. And the reason that we're getting a lot of errors, well, first of all, we haven't imported anything. Cosmos.system.graphics, system.drawing, and I'm just gonna comment this out for now because we're gonna be making the font class later. But we're still getting an error, so it's asking for the constructor, which is just this. We have to add the required x and y values for the constructor and pass them over. So, same thing that we did with the command, if you remember. If you don't, go ahead and take a look at it, or go back in the video. All we have to do is pass the parameters over. And with the commands, as you can see, we didn't actually add anything extra to the constructor. But for the console tab, we are, because we have some unique things that we have to set, such as the console text pen, which is just the color of the console. We'll just set its default value to white. And yeah, we'll come back to this later. But if I go to my tab bar, as you guys remember, we were just opening an empty basic tab. What we're gonna do is just make it a console tab so that now it'll open our actual console window. And now what we're gonna go ahead and do is create the actual font class. And what we're gonna do is right click on Practice OS, add new item, font, because we don't actually want another folder for it because it's only one class, so we'll just put it with the kernel. and we'll make it public. So, as you guys remember, the C#, as I was explaining earlier, C# takes files and reads their bytes, not their bits. We're gonna have to do that ourselves. These are bytes. These are bytes. Well, I'll make that more clear. These are bytes, but these right here are bits. And C# doesn't read bits, it reads bytes. So, what we're gonna do is get the byte data. We're going to want to be storing that. And we're also going to want to know something like how many bytes per character. So, for example, if you have 8-bit, as you can see, there's 1 byte per line, because 8 bits is 1 byte, and we have 1, 2, 3, 4, 5, 6, 7, 8 lines. So it's 8 bytes. And the reason that's 8 bytes and 8 lines is just that's a square. It doesn't look like a square, but when we actually interpret it on our operating system, it will be a square. And let's say I have a 16-bit font quality. It's gonna have 2 bytes per line, and then 16 lines. So now that becomes 32 bytes per character. And we're gonna store how many bytes per character in a public read-only, and we're gonna make a uint16 because we don't need uint16 stores values 0 to 65535. There's not gonna be more than 65535 bytes in character. If there was, that would be a very, very large file and very laggy. And then we're also going to want to store the bits per line. This might be a little bit misleading. I'm storing it in a byte, but the only reason I'm storing it in a byte is because a byte can store numbers 0 to 255. And as you can see, there's 16 on this one. If I made it 32-bit, there'd be 32. If I made it 64-bit, there'd be 64. There's no reason to go above 255. We don't want to waste the memory, so that's why we're making it in bytes. And yeah, that's as far as the variables go. That's it. So bytes per line, or no, my bad. Bits per line, bytes per character, and the bytes in the entire file. Now we're gonna obviously want to get those datas. So how do we do that? We make a constructor. Not the first time we've done it. That's how we get the data. And for the constructor, all we're gonna do is take in the data of the font. So for example, all of this here would be what we're going to put in this byte array. And we're just going to store it in our data variable we made. And as you guys remember, probably, the first byte is the header. And the header just tells you information about the file, as I explained earlier. So what we're going to do is switch the first byte. So the way we do that, we select the data, which is all the bytes, and we select the first one. And now we'll be selecting this first byte, or this first byte, depending on whatever file you have. And in the case, we did a switch statement before in file, if you remember. So that's all it is. And in the case that it's a 0x00, that means it's 8 bits. So there's 8 bytes. I already showed it. I don't really want to draw it again because I did it a bunch of times, but there's 8 bytes per character and 8 bytes per line. And in the case that it's 16-bit, which would make the header 0, 3, 32 bytes per character, 16 per line. In the case that, I didn't show you guys this, so I'm usually going to take my word for it, but in the case that it's 32-bit, that would be the header 0F, the take would be 128, the BPL will be 32. This doesn't really matter, because we're not going to be making this good quality fonts yet, at least yet. You guys can if you want, but like, I don't really want to. And 64-bit would be that. And if the header is invalid, if it's not any of this, that means that invalid file, because we expected the first byte to be one of these. So if it's not, that means it's not it's definitely not the file type that we want. We're done with the constructor. Now what we have to do is go ahead and create a few functions. But first, before we make those functions, if you've ever programmed in C#, you'll know that you might know that there's a namespace called system.link. And I love this namespace, but I haven't been able to use it because it doesn't work in Cosmos. The only issue is this is impossible to do without a few functions from that namespace. So just under here, I'll create a public static class LINQ substitutes. So we'll be substituting for LINQ. And so a lot of you guys might not know all of the methods that are in the LINQ namespace. All I'm going to be doing is recreating them, and I'll be explaining them. So there's a method called skip, and it takes bytes, or any array, but we only need it for bytes, so we're just saying bytes. And it skips ahead a certain amount of times in the array. So if, for example, if I set this count to 7, then that means that it would skip the first 7 bytes and give me an array that is 7 to the finish of the array. It starts at 7 and goes to the finish. And if I put 13, it would skip the first 13. It would go 13 to finish it for the array. So the first thing we do is create the list byte data. And these are all things that are in C# normally. I'm just recreating them because they don't exist in Cosmos. And then we'll create a counter. And I'm going to create a while true loop. It's not going to go on forever though, because you can always put break and then it'll stop it. That's kind of interesting that it lets me compile this, but anyway, try. We're going to put try loop data.add bytes counter catch break return data and increase the counter. This is a little bit of an unconventional way to do this. I'm sure that basically everyone else on planet Earth would have a different approach, but it works completely fine and I don't see a problem with it. So the issue, or not the issue, the way it works is that it goes through every single, oh my bad, I nearly messed this up. This has to be count. It starts at the count, and then it goes through every single byte in this, and from these bytes, starting at the count. So that means that it will skip ahead to whatever the count is, and then it adds them all to this list. And the reason that the try catch loop is here is because it will keep doing it until I get an error. and the error will be out of bounds. The counter is too high. It is above the maximum, it is above the amount of bytes in this array. And then when that error happens, it'll go to this catch statement and it will stop this loop. It will stop this loop, and then it will return the data. Well, the next thing is take it's similar. What this function does is it will take, let's say you have an array of 16 bytes. If I say to take 8 bytes, then it will take the first 8 and give you a list of the first 8 bytes from this list. And if I set this count to 12, it would give me the first 12 bytes from this list. So we do the same thing. We create a list of data that we're going to return later. And this time, we set the counter to 0. And while the counter is less than or equal to count, we will add the byte and increase the counter, and then finally we will return the result. The last method, this actually isn't in LINQ, but it's not even in C#, so we have to do it ourselves. And all we're doing is taking one of these hexadecimal numbers. That's what they're called. These bytes are called hexadecimal numbers. And we're converting it to binary, which is this. Or this. These are both binary bytes. And we're converting it into a string, so it would actually be this, as I mentioned earlier. And then we're taking in the byte. And the reason that I'm putting this here is because now, if I have any byte A, I will be able to now take A and do .to binary, because this is here. And if this wasn't here, then I would have to do this. Which is just a lot longer than doing that. And this will still work, but you know, this is a lot shorter, obviously, and you can now do it in shorter amount of space. Same reason I put this here and this there. But let's actually get on with the method. We're going to take a string builder, because as I said, whenever we're making a string in a loop, we use a string builder. And we're going to set its capacity to 8. We know how many strings we're going to have to, we know how many characters we're going to have to build. There's 8 numbers, there's 8 zeros and ones in a binary byte. So we know that's going to be 8. We might as well set it. Same thing for, I'll just take the suggested name for this array of integers. We know there's going to be 8, so we're making a list of integers 8. And now we're going to make a byte I equals 0. This is just a counter. Alright, it's just a counter, and we're going to say while I is less than the length of this array, then this is where things get a little bit complicated. You don't have to understand this fully, because all we're doing is converting it to binary, and if you understand that, you're golden. But what I'm doing is I'm going to go in this array, and I'm going to get the length of the array minus 1, because it goes 0 to 7, and so we have to subtract 1, because right now it's thinking it goes 1 to 8, but it actually goes 0 to 7, so we're subtracting 1. And then we subtract I, because actually what happens is when you're making something into binary, you have to go backwards in C#. And now what we do is there are these operators in C#, bitwise operators, byte operators, and you might have not seen them before. I'll show you some of them. B, and then you could put the ampersand. And there's also this one. And those are both operators that you could include to modify binary values and stuff like that. And then right here, this question mark, and this right here, this colon, they're ternary operators. If you want to do some research on them, just Google it. It's called like ternary operator, C#, I think. I'm not entirely sure. All I know is I love them and I abuse them so much. Like, I'd use them when I shouldn't. But here's a good place to use them. I've neglected using them in this entire operating system now that I think about it, because I just haven't found a place to use them. But basically what they do, so you write down this, and as you can see, this is a boolean, because it's checking if this is not equal to 0. And when you put this question mark here, it's saying if this is true, then set it to 1. And if it's not true, set it to 0. And what we're setting is an integer in this array. Then we're going to increase I so that we can continue the loop. And now we're going to go through every single number in the integer array we made. Which in hindsight, we could make it bytes, but like, I'm not going to change it right now because I don't want to change anything because it could mess something up unexpectedly. And so right now we have every single binary digit stored in this array. Now we're just going to put it into a string so that we could better use it. And then we'll return the string builder.toString. We used string builders before. When you do toString, it just converts it to a string. And we're done with our LINQ substitutes. Now what we have to do, now that we have everything set up, what we have to do is say, make our functions in font. And the functions we're going to be making public byte array get raw data and public list tuple uint16 boolean get data at. Now, I'm just gonna get rid of that for now, because it's causing errors that I don't really want to solve right now. But is that? Oh, that's the issue. Whoops! I accidentally put a comma instead of a bracket right there. Anyway, now, before you saw me use tuples with points and colors. The logic behind this tuple, the first number is x and the second number is y, so it's kind of like a point, except I'm storing them in smaller data types so we don't use up more memory. And the boolean is the color as well, except it's black and white. You can either write true for black or false for white or background or transparent or whatever. We're going to make another string builder here. And we're going to create another list of this type. That's just going to be the return data, because we're going to be returning it. I really don't like the way that this is automatically set up. regardless, now that we have all that set, all these initialized and set up, we need to create the get raw data at function that I was trying to make earlier. The parameter we're going to take here is a index. We can do this on one line. All we're going to do is return this.data.skip, which is the function we made down here. 1 plus this.take, bracket this off, this.take times index, dot take, this.take. Now, I realize that this might be a little bit overwhelming. So what we're doing, let me open a file, for example. So, say that we want to get the third character in a file. This is what we do. Get raw data at 3. Or like it would be 2 because it starts from 0. What this will do is first it's going to go into the data, which is this entire thing here. It's going to skip the header. And the way it does that, it skips 1. And now it's skipping this byte right here, which is the header. And starting here. Then, if you remember, this.take is equal to the bytes per character. So, since I want the third character, it's going to take the bytes per character and multiply it by 2. And that means it's going to skip the bytes of 2 characters. So it will skip ahead, and then imagine that this right here is where we're left off. I don't know if that's accurate, but imagine this right here is where we're left off. Then it takes the amount of bytes per character. So it will then select 1 character. And it will return this chunk, for example. And this chunk is going to have the byte data for 1 character. So basically say that I make the A again. That's like not really good looking A, but it's gonna get me, this is equal to FF and this is equal to like C3 or something. It would get me every single byte. So FF, C3, FF, C3, 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 and store it all in the return value list. That's what's called get raw data, because it just gives you the bytes, a raw amount of bytes that contains the data for 1 character. And that's why we need it. We need to get the raw byte data before we can actually get the converted to string data and then later display it on the screen. So what we're going to do is loop through every single byte in this.get raw data at, and then the index, because we pass the index down. We're going to append to the string builder, and what we're going to do, convert it to a binary string, and it will take these so right now it has a bunch of FFs and C3s. It will convert them into this as a string. So now, what we have to do now is pad left 8 0. Don't worry about what that is right now. It'd take up too much time to explain something so minor, but just know that it just helps convert it to binary. And now sb.toString is gonna look like, say that we're getting this character. Now it's gonna look like that's what's gonna have. It's gonna contain all of the characters data as a string. But now what we have to do is go through since it's in that format, we're gonna have to get the X and the Y of each character, because as you guys remember, we're returning the X y, and whether or not it's colored. Set the x and y to 0, and then what you want to do is get the fixed BPL. So you might be wondering, why do we need to change the bytes per line? And that's because it's 0 based. So we want to, as we did with back here, by subtracting it by 1, we want to subtract it by 1 because it's 0 based. And with 0 based, that basically excuse me. So there are arrays in C#, as you know, and they start at 0. That's all that 0 based means. It means it starts at 0. So that's why we're subtracting it by 1. And now we're going to loop through every single one of these digits. They're really characters, but you know, we know that there's zeros and ones. And what I'm going to do is say add it to the return data. And as I said, the first number in the return data is the x, the second one is the y, and now you may be wondering, how are we going to figure out if it's colored or not? Well, easy. Remember, as I said, if it's 1, it gets colored. If it's 0, it doesn't get colored. So, color it if it's 1. That's all I'm going to write there. But it's not all fine and dandy, because we haven't actually set the x and y values. This is where things get a little bit complicated. So if we look back here, what we're going to do is say if the x is equal to fixed BPL, then increase the y. And the reason we're doing that is, and we're going to increase the x down here as well. So what it's going to do, it's going to increase the x. So it's going to go through this. It's going to say, oh, okay, do we draw here or not? Add it to the list. It's going to do it for this number, this number, this number, this number, this number, this number. But when it reaches this number, how is it going to know that to increase the y? How is it going to know to go to the next line? Well, we check if it has reached the bits per line. So the bits per line is 8 here, for example. If x is equal to 8, then we increase the y, so now it knows to start here. And when x is equal to 8 again, it will know to go here again. And then, but obviously, we have to set the x to 0, because on the new line, it doesn't just keep going like here and all, you know, it would just, it actually starts back at 0, so we have to set x to 0. And this is it, actually. That's the font class. Now, if you guys remember, we made a tab component. And these are basically just the things that are on the tab. So for example, I'll explain it again. If you look on my screen, as you can see at the top left-ish area, this is a button. That would be a tab component. Anything on the screen would be a tab component. This would be a tab component. This entire text box here, this rich, where we write all of our programming code, that would be a tab component. So we're gonna have to make a new one of those. And luckily, I just realized I forgot to type one line in here. Return data. So let's go into graphics, add new item. Oh shoot. Return data. That's what I meant to say. Back to what we were doing. Go into graphics, right click it, add new item, class, text. And how do we make it a tab component? Well, the same way that we made our commands and our tabs. Tab component. In text, you can, if you've ever worked with WinForms, making your own C# applications on Windows, you can consider text as a label. It's just a lot simpler, and that's why I'm naming it text. A lot simpler and more native. And what we're going to do first is create a few static properties. And the way that our file works is it stores characters in this order. I'm just like, it's just kind of like the same order as your keyboard kind of for the symbols. And the reason we're doing this is because, as you remember, we can't search up a character. We have to search up an index. So we'll just simply know that, as you can see, if I wanted a capital N, all I have to do is say the capital N is located at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's the 13th thing in our characters. So if I wanted to get a capital N, I would go to my font, I would use get data at, and for index I'd put 13. Now we can make our public font the text of our component and the color. So obviously when we're writing text, it needs a font, text, and color. I'm going to just quickly import the pen. And as usual, constructor to set all of these, but we need to, since it's a tab component, it has x's and y's. It has x and y required, so we have to put that. And then we could put after that all of our other things. And byte size equals 0 or equals 1, just because right now we're just gonna set it to 1 because we're not gonna account for size yet because that's a lot of work, and we're running short on time again already. So import the required parameters in the base. As you can see, this is the base. It requires those 3. We send them in. And now we'll open this up so we can set the things that we need to set. And I'll set it in the correct order so it looks better. Now, if you guys remember, in our tab component, we also had the draw, and this is where you can explain for your tab component how you want it to be drawn. No point in doing base.draw because base.draw does literally nothing. So simply delete that. Now, even using this font class, we still have to take the return value and we have to modify it again. We're not done with it. So what we're going to do is go through every single character in our string here, in the text of our label. I'll just call it a label for now. This is what this tab component is. It's basically a label, and a very simple one. Go through every single character in the text string, and well, it's our draw function, so we have to draw it. So what do? Well, the first thing we gotta do is we don't, if you notice up here in our characters, we didn't actually make a space in our font. And what this counter variable I did made, what it's for is it basically it's the x-axis of the character. So if I didn't have this, then all of the characters would be on the same x-axis overlapping each other, if that makes any sense. So if the character is a space, we have to tell it, well, make a space. And how big is that space going to be? Well, it's going to be the bits per line of the font, because that's how big the other characters in the font are going to be. So we want it to be even and consistent. And now, this is where we actually draw the character. We're going to loop through the X, Y, and Boolean, draw or not, pixel data of the function, the method we just made. And now, if you remember, I was explaining on how to get the index of any character. It's very simple. All you have to do is write this: text.characters.index of the character that is in the string. And it gets the first index of the character. So if I put J in, for example, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what this would return. And now, what we're going to do is say, is that, now, if you remember, we have a Boolean here that tells us whether or not to draw the pixel. If it's a 0, don't draw it. If it's a 1, do draw it. So if we are drawing it, if pixel data item 3 is the Boolean, then, well, we draw it. Because the get data at function, you could consider it instructions, not actually images. It's just instructions to create a letter. It's not actually the letter. That's probably the best way to explain it. And now, go back to my text, to my label thing. Kernel.gy.canvas.drawPoint, and then we're going to select the pen. I did not mean to do that, but you get the idea. We're selecting the pen. Oh wait, I didn't mean to do that, never mind. We're selecting the pen, and we're going to create a point out of the X and Y values that I got here. And the way we do that is we're going to, as you remember, we made a counter that's going to count how many characters they are, so we know to put a space over them. So we're increasing it by counter. And then we also want to make sure that, say that this is our screen and this is our window, we want to draw the text here, not here. So what we do is we want to check the coordinates of the sender, which is the tab that it's on, and get the X value so that it prints here instead of here. And it's aligned. Same thing for the y-axis, except we're not actually going to put in the counter, because it's going to draw on the same y-axis. That won't make them overlap. They only have to change the x-axis. And if I did add plus counter here, what it would do, I imagine, is it would make text look like this. And if I didn't add the counter axis on any of these, then this is how it would look like. So I hope that helps you better understand why we're using the counter variable. But also, we don't want the text to be drawn here. We want it to be drawn here. So we're going to skip ahead at the size of the top part of the tab. And as you remember, we stored it in tab dot window top part size. plus, and now if you remember in our tab components, there's the x and y's of the component itself, and we haven't accounted for those, so we'll account for those right here. Otherwise, the user wouldn't be able to draw it here. They would only get the option to draw it at the top of the tab if we didn't include that. And now all we do is increase the counter by the bits per line, and we're gonna check if if the next character is gonna go off the form. And if it does, then we're gonna just check get the form size. That's how we're gonna do it. And if it does, then we're done. We're not gonna draw any more characters. It's because it's going off the form. We don't want to draw them. The final thing we have to do is go back to our console tab, and now we could finally set the font. Just kidding. I just realized that we don't actually have the data of our font in our operating system. Now, I actually made a little application to do it for me, because basically when using VMware, which is the thing that runs our operating system in a virtual environment, you have to pay to be able to directly put in your own files. And I'm not paying, to be honest. Like, I don't know, I'm not gonna pay. I don't expect all of you guys to pay, so this is how we're gonna do it. I'll remember to put this in the description. I'll put this in the description so that or like, if it lets me, I don't know if it's gonna be, I'll like figure out a way to put it in the description. I'll like upload it to Pastebin or something so that you could do this yourself. And I'll show you guys the application that I made. It's just this. All you gotta do is put in all of the data of your font, like copy all of this. I'll do it right now. I mean, actually, I'll just do it after I do this. So I'm gonna go to my I'll do it in text, and I'll say public static byte array default font data equals new array. You put these brackets in, and all you do is paste that there, and then it will work. Just like that. And I'll show you guys the application now. All you do is you copy all of this, all of the byte data of your font. I'm using mEditor. There's online alternatives too, like I was using hexed.it earlier in the video. This is the application. I'm not going to put it down a link. You can make it yourself. It's very, very, very simple. And you just put all of it in data. Control V, I paste it all in. And then you run it. I didn't name it that for any specific reason. I just, like, face rolled them on my keyboard. And now it's actually going to return this. This is an issue with C#. It doesn't put it all in one line. All you want to do is just go to the last line and backspace it, and then you just keep doing that until it's all on one line. I'm not going to do it because it's 92 lines, but like, you would just keep backspacing it until it's all one line, just clicking on the very bottom left last line and then backspacing it, and then eventually it'll all be on one line and you copy it. And that's how I got the data. And what I'm gonna do now is go back to my console tab, and now I'm able to make a font using that data. So I just select it, default font data, run. Actually, okay, that's good that happened anyway, because I didn't actually make any text that says anything. So what I'm gonna do is make this dot add component. I'm actually very lucky that happened. I would have had to wait, but anyway, we're gonna draw some text at 0, 0 on the form, and since it's gonna be a console, we'll just give it a little bit of information about Practice OS, because that's kind of what Windows does. It does it like, it gives the copyright, but like, you know, it doesn't matter that much. And now we select the font, and then the pen. And under that text, we will make another text. Call it, since we're gonna make a console, we'll type help for help, because that's one of our commands. And I'm gonna see where this issue is. It's just at the end here. I forgot to put a colon or semicolon. So yeah, in the description, I'm gonna put the I'll go on my GitHub right now. I'll just put all the links in the description while I'm waiting for the operating system to load. Here's more information about it if you want to read. And then, I don't know if you could download things directly. I am able to download it. So I'm going to just give you guys the link to like this, so that you could download it and then run it. And then I haven't actually ever done this. I'm gonna see if it works fine. Yeah, and then you could just make your font. And if you only want to do letters and numbers or something, then just type save early in here, and then press this button, and then you could just save it. Otherwise, it'll save automatically whenever you've reached the 98-second character. idle CPU is now taking 57 seconds. Nice. But yeah, I'll include the link for that right in here. And then right now, I'm gonna make a paste bin. That's just gonna contain this entire line right here. This huge line that contains all the byte data. There. And those are the two links I'll put in the description. The text editor I'm using is called M-Editor. It's really good software. You won't hear me say that about almost any software. It's really good. M-Editor and Sharp Develop, good software. Even though it's Sharp Develop is outdated as hell. Yeah, these compile times are not gonna be nice to me. They are gonna just eventually it's gonna be like 10 minutes to compile it. Probably not, but maybe. Just click on the console button to launch it. It's just gonna take 7 seconds. 4, 5, 6, 7. And that's my handwriting, guys. That is my handwriting. You could drag it around. But yeah, that is my handwriting, folks. That is my handwriting. It is very impressive, I know. But you know, it works. Looking at this now, I would definitely recommend you. I don't even know, like, that is so bad. That is so goddamn bad. But it works. The purpose of this is not for it to be pretty. It works. I said earlier that Disclaimer, I'm not an artist, so yeah. Anyway, that's the end of the video, guys. See ya.